What if we've already heard the first whisper of alien life, and it came not from a signal in space, but from a silent rock buried in the red dust of Mars? In a forgotten lakebed called Jezero Crater, NASA's Perseverance Rover may have uncovered the most compelling clue yet. A pattern in stone, a signal written in minerals and ancient chemistry. Not proof, not a fossil, but a fingerprint, one that speaks of water, of time, and perhaps of biology. This is the story of that whisper, the closest evidence yet of life on Mars and what it means for all of us. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. Beneath the surface of Mars, hidden beneath layers of ochre, dust, and time, something ancient waits. Not a fossil, not a ruin, but a pattern, a fingerprint perhaps, a whisper etched into stone by a hand we cannot yet see. It's here, in a crater once filled with water, Jezero Crater, that a robotic explorer named Perseverance has begun to hear it. On Earth, life announces itself with thunder. From coral reefs to rainforests, it thrives in motion and color, complexity and noise. But if life ever stirred on Mars, it would have done so differently. Quietly, humbly, in the shadows of time. It would have left no forests, no bones to bleach in sunlight, only chemistry. But sometimes, chemistry remembers. In February of 2021, NASA's Perseverance Rover descended into this desolate basin, guided by fire and math, landing softly in what was once a Martian lake. Jezero Crater had long been chosen for its geological story. A river once flowed here, carving deltas, pooling sediment, inviting time to layer itself in clay and mud. Where there was water, there may have been life, and where there was life, there may still be clues. That clue now has a name: Sapphire Canyon. What Perseverance has found is not a creature, it is not a fossil, it is not even a cell, it is a rock core, pulled from the Martian subsurface, bearing within it organic molecules co-located with minerals that, on Earth, often form in the presence of microbes. The mudstone core, now named Sapphire Canyon, is not remarkable for what it shows, but for what it suggests. Organic molecules are not rare in the universe. They've been found on comets, in meteorites, even floating in the gas between stars. But context is everything. These organics are nestled in leopard spot, textures, concentric mineral halos rich in iron, sulfur, and phosphorus, with clear signs of redox reactions. And it's those reactions, those subtle shifts in electron energy, that bring the possibility of life into view. On Earth, such mineral patterns emerge in anoxic sediments, places where oxygen is scarce but life still stirs. Swamps, muddy lake bottoms, underneath the sea. In those places, microbes manipulate iron and sulfur, like artists etching patterns of life into stone. The same mineral combinations seen here, vivianite and greigite, are often born not from chaos, but from metabolism. Not always, but often. This is not proof. It is not even confirmation of biology, but it is something NASA is calling the clearest sign yet, the potential biosignature, which begs the question, what makes something a signature of life? A biosignature is not a single thing, it's not a skeleton, it's a pattern, a relationship, a fingerprint of processes that resist entropy of matter, organizing itself in ways that, by all rights, shouldn't happen without purpose. On Earth, these patterns usually mean biology, but on Mars, where chemistry can run unchained for billions of years, the same signs could emerge from non-living forces. That's the paradox. We are trying to find life by looking at rocks and molecules, by interpreting silence as if it were language. But maybe that's what Science Island A way of listening. And what Perseverance has heard deep beneath the ancient lakebed is a whisper. It speaks in hydrogen bonds and mineral halos, in concentric circles and fragile carbon rings, a whisper that might say, "I was here," or perhaps, "I could have been." Let us not rush to hope. History has warned us before. The Viking landers in the 1970 seconds hinted at life, then fell into ambiguity. A Martian meteorite found in Antarctica in 1996 seemed to show fossilized microbes until it didn't. Even methane plumes, once the darling of Martian biosignature headlines, have failed to draw a clear line between geology and life. But this is different, because for the first time, organics, minerals, and textures have aligned in the same place, the same space, the same story. And that story unfolds in mudstone, a rock that forms slowly, gently, in water. Mudstone is not violent. It does not erupt or crash or boil. It settles. It remembers. And in that stillness, it can preserve things fragile and ancient. A molecule, a layer, a trace. In Sapphire Canyon, what was preserved is not just chemistry. It is possibility. Possibility that 4 billion years ago, Mars was not a dead world. That in Jezero's calm waters, life sparked not with thunder, but with a whisper. That the elements carbon, iron, sulfur were once arranged by something more than chance. And that maybe, just maybe, those whispers have reached us. But the truth is this: we cannot know for sure, not yet, because Perseverance, brilliant as it is, cannot test chirality. It cannot analyze isotopes with atomic precision. It cannot peer at the nanoscale textures where biology leaves its secret marks. For that, the rocks must come home, to Earth, to laboratories, to human hands and human doubt. And so, the most important evidence ever gathered on Mars now rests in titanium tubes, sealed and waiting in the dust, for a mission that may not arrive for another decade. The Mars sample return, the next step in this cosmic relay. Until then, we are left with the whisper, the quiet suggestion that we are not the only outcome of the cosmos, that life, even microbial, even ancient, may not be unique to Earth, that the universe may breathe in more than one place. And if that's true, then everything changes. Not just science, but meaning, history, philosophy, our place in the great unfolding of time. So we begin here with a rover in a crater, drilling into red rock, listening for life in the form of silence. And what it has found might be the beginning of an answer. In every grain of sediment, a choice was made billions of years ago to decay or to persist. Imagine the bottom of a lake, not the shimmering surface where light dances, but the silence beneath, where sunlight fails and oxygen fades. On Earth, these are the places where life still thrives, hidden kingdoms of microbes that do not need air, only minerals, electrons, and the slow patience of time. They leave behind no forests, no coral reefs, no thunder of whale song. Instead, they etch their existence into stone, weaving microscopic patterns into the mud. And billions of years later, those patterns can still be read, like ghostwriting on the page of the Earth. Now, imagine such a page, not on Earth, but on Mars. Perseverance has drilled into that page, into a mudstone core drawn from an ancient outcrop known as Bright Angel in Jezero Crater. Within this stone, the rover's instruments revealed something uncanny: leopard spots, concentric halos, mineral rings that seem to echo the hidden work of life. Not proof, but suggestion. Not shouts, but whispers. The spots are not random stains. They are chemical dialogues, places where organic molecules are found precisely where certain minerals appear. Those minerals, iron, sulfur, phosphorus, do not simply drift together by chance. They form patterns tied to redox reactions, the quiet tug-of-war of electrons that drives much of life's invisible machinery. On Earth, microbes have mastered these reactions, feeding not on sunlight but on gradients. Iron pulled from rock, sulfur shifted into new forms, phosphorus locked into crystals. These processes leave fingerprints, not in bones, but in minerals. Here on Mars, two minerals draw particular attention: vivianite and greigite. Vivianite is a deep blue phosphate, delicate and striking when exposed to air. On Earth, it grows in waterlogged, oxygen-poor sediments, marshes, lake bottoms. peat bogs always in the company of decay and microbial activity. It is a mineral that thrives in stillness, in the quiet metabolic exchanges of the unseen. Greigite, by contrast, is a magnetic iron-sulfur mineral, cousin to the pyrite that glitters in Earth's rocks. But greigite is no mere sparkle. In some of Earth's oldest sediments, greigite clusters around microbial life. Certain bacteria even use iron and sulfur cycles to fuel themselves, leaving greigite as a shadow of their hunger. Together, vivianite and greigite are not just minerals, they are signs of a dialogue between matter and metabolism. To find them together with organics, nestled in leopard spot halos, is to stumble on a scene that feels almost familiar. On Earth, such a pattern would be explained first by biology. Microbes at work, shifting iron, binding phosphorus, weaving carbon into molecules of their own design. A living chemistry painting itself into the mud. But Mars is not Earth. Its chemistry is older, stranger, freer from the constant editing of biology. The same signs could emerge through abiotic processes, minerals forming through slow, natural reactions, catalyzed by the planet itself. And so, we hover between awe and restraint, between the thrill of recognition and the discipline of skepticism. Yet here is the haunting question. Why do these minerals, these patterns, these whispers, look so much like those we know to be biological on Earth? Why, in a world billions of miles away, should the same signatures emerge? Coincidence or kinship? The mudstone remembers. Long after water vanished from Jezero, long after Mars dried and froze, the chemistry remained. Locked in those leopard spots is a frozen memory of a time when lakes rippled here, when rivers carried silt, when the possibility of life was not absurd but inevitable. And Perseverance, drilling into that ancient silence, has brought the memory to us. In every grain of sediment, a choice was made. On Earth, that choice birthed forests, oceans, us. On Mars, the outcome remains hidden, sealed in mineral ghosts. But now, for the first time, the ghosts have faces rings of vivianite, halos of greigite, organics whispering between them. This is why NASA calls it the clearest sign yet, because these aren't just random traces. They are co-located, interwoven, consistent with what life does when it works in darkness and mud. They could be coincidence, yes, but if they are not, if they are what they seem, then these spots are the shadows of Martian biology itself, etched into the bones of a vanished lake. The ghosts of the mud speak. We may not yet know what they say, but we know enough to listen closer. And in that listening, something stirs. The possibility that the story of life is larger than Earth, that it once reached across the gulf to paint itself into Martian stone. Some lakes vanish in time. Others stay, carved into stone, waiting to speak. Long before Jezero became a crater of dust and shadows, it was alive with water. A river flowed in, spreading into a vast delta, a fan of silt and minerals, unfurling across the Martian surface. The delta was not just a structure, it was a memory machine. Every flood carried stories, every grain of mud settled in layers, and each layer became a page, pressed into stone, holding a record of a world that once had rivers, rain, and the possibility of life. When Perseverance drills into Jezero's rocks, it is not piercing stone, it is opening a book written in water. Mudstone is that book's most delicate chapter. It is built not by violence, but by patience. Particles carried by calm water, settling slowly in silence. Layer by layer, mudstone records the quiet breathing of a lake. On Earth, these rocks become archives of microbial mats, traces of ancient ponds, even the earliest whispers of biology itself. In Jezero, they may hold the same. The Bright Angel outcrop, where Sapphire Canyon was found, is one such chapter, a place where the Martian river once slowed, fanning out into a shallow lake. Here, organics and minerals wove together, captured in concentric halos, preserved in mud that turned to stone. These rocks are not explosions frozen in time, nor mountains worn by erosion. They are sediments soft, layered, gentle, and sediments, more than any other rock remember. Think of a lake on Earth. Beneath its surface, a story unfolds in silence. Light fades, water stratifies. In the darkness of the bottom, oxygen disappears, and yet life adapts. Microbes feed on iron, sulfur, and phosphorus, drawing energy from gradients invisible to the human eye. They leave behind not skeletons, but geochemical scars, patterns in the mud, shifts in minerals, traces that last long after the microbes themselves are gone. Now lift that scene from Earth and set it down on Mars, billions of years ago. A lake with no fish, no reeds, no birds overhead, only microbes, perhaps, drifting in the still water, clinging to the sediment, leaving their whispers in the mud. Over time, as the lake dried, as Mars turned colder and thinner, those whispers fossilized into textures. And now, across eons, they meet us again. Jezero's layers are not uniform. They hold contrasts, dark and light, coarse and fine, organic and mineral. Each tells of changing conditions, floods, droughts, shifts in chemistry. On Earth, such cycles often correspond to cycles of life. Could Mars have known the same rhythms? Did microbes bloom when waters were calm, retreat when chemistry shifted, adapt as their world changed? The paradox is haunting. On Earth, mudstone layers teem with stories we can read easily: fossils, isotopes, microbial mats. On Mars, we hold only hints. The same textures, the same minerals, the same organics, but stripped of certainty. We are left to wonder, are these truly the echoes of life, or the tricks of a lifeless planet sculpted by time? And yet, the setting matters. Jezero was not a random crater. It was chosen for its delta, its preserved lake, its promise of long-standing water. Of all the places on Mars, this is the one most likely to preserve life if it ever existed. This is the basin where rivers once converged, where clay minerals locked away secrets, where organics could hide from radiation for billions of years. It is not just a location, it is the stage on which life could have written its first act on Mars. To stand on Jezero's shore in your imagination is to see two worlds at once. One is today's Mars, cold, barren, silent. The other is a ghost world, waves rippling, deltas building, sediments sinking, and perhaps unseen, cells dividing. Both worlds are real. One is preserved in memory. The other is buried beneath it. This is why the mudstone matters. It is not only geology, it is potential biography. It is a story not of stone, but of survival, of how fragile life, if it arose, might have chosen to etch itself into permanence. Each leopard spot, each mineral halo, each grain of organic carbon is not just a chemical curiosity. It is a syllable in a story written billions of years ago, waiting for us to learn the language. Lakebeds remember because water is the great archivist. It gathers, it buries, it preserves. And when the water is gone, what remains is the testimony of its presence. On Earth, the oldest signs of life are found in ancient sediments, microbial mats preserved in rock, isotopic signatures in stromatolites, whispers carried by water into permanence. Why should Mars be different? Why should its lakebed not remember as well? Perhaps that is the deepest truth of Jezero. It is not that it proves life, it is that it insists on memory. Even a barren planet remembers its wetter self. Even in silence, the lakebed speaks. And when Perseverance drills into its mud, the rover becomes less a machine and more an archaeologist, brushing dust from pages written in the language of time. In these pages, we glimpse more than chemistry. We glimpse continuity. Mars was once like Earth, wet, dynamic, alive with potential. Earth is now a flourishing world, a riot of biology. Mars is silent. Which of these is the anomaly? Which is the norm? The lakebed forces the question. If life began here too, why did it not endure? And if it did not, what does that mean for us? Lakebeds that remember do not answer. They only whisper. They leave us with fragments of a story, the pieces of a puzzle half assembled, but even fragments matter. They remind us that memory is not erased by time, it is only buried, waiting for the right hands to uncover it. And so, in Jezero's mudstone, we may be touching not just Mars's memory, but our own, the memory of what it means for life to try, to exist, to leave something behind. The memory that even silence can be a kind of survival. To find organics is not to find life, but it is to hear a breath across eons. There is a dangerous word in astrobiology, organic. It is dangerous because it carries too much weight, too much longing. To the public ear, organic molecules mean life, but to science, the truth is subtler, quieter, more humbling. Organics are molecules built around carbon rings, chains, and frameworks that are the scaffolding of life. They are necessary for biology, but not sufficient. They are the alphabet, not the poem. NASA's Perseverance Rover has detected these organics in the mudstone of Jezero Crater, not once, not vaguely, but precisely mapped with its instruments, confirmed in multiple samples. The rover carries an ultraviolet spectrometer called Sherlock and an elemental probe known as Pixel. Together, they scan stone not as inert matter but as living text. And in the concentric halos of Sapphire Canyon, Sherlock saw something extraordinary. Organic signals aligned with mineral fronts, carbon-based molecules, exactly where life would have placed them if life had ever been there. But the paradox remains. Organics are not rare. They rain down on Earth every day, delivered by comets and meteorites. They have been found in the cold hearts of asteroids, in the methane haze of Titan, in the interstellar dust drifting between stars. The universe is a factory of organics. And yet, most of those molecules are not alive. They are raw ingredients scattered widely, waiting for something more. So why do the organics in Jezero matter? Because context is everything. On Earth, organics alone would be unremarkable. But organics woven into redox gradients, organic carbon where iron and sulfur shift their states, where phosphorus binds into minerals like vivianite or something else. They are not random. They are co-located, structured, patterned. It is the difference between letters spilled across a page and letters forming words. Consider this. Life, in its simplest form, is an interruption of entropy. The universe tends toward disorder, but biology holds disorder back, at least temporarily, by organizing matter into improbable shapes, enzymes, membranes, proteins. When Perseverance finds organics in lockstep with mineral textures, it hints at organization. It suggests that carbon did not just fall there, it was placed there, arranged by a process that remembered gradients, that mirrored metabolism. This is not proof, it cannot be, but it is possibility sharpened into something visible, a shadow of order. NASA calls it a potential biosignature. That word potential is both careful and thrilling. It means the evidence passes a threshold, strong enough to inspire, but incomplete enough to restrain. Peer-reviewed, vetted, acknowledged as the clearest sign so far, but still only a sign. The word itself is a mirror of our longing, potential, waiting, not yet, but maybe. And here lies the existential tension. Humanity's story is one of searching for echoes of itself. We have scanned the skies for radio waves, searched exoplanets for chemical imbalances, drilled Antarctic ice for buried microbes. And now, in Martian stone, we see organics nestled where life would have left them. Are we seeing Mars as it was, or as we hope it to be? The answer may rest in subtle details. Some organics form through abiotic pathways, chemical reactions catalyzed by rock and water without biology. Others form through life. On Earth, we separate them by looking deeper. The isotopes of carbon, the chirality of molecules, the exact structures of rings and chain. These are the fingerprints of biology. But Perseverance cannot see that deep. It can only tell us, yes, organics are here. Yes, they are in the right place. Yes, they are patterned. But no, it cannot tell us if they lived. And so, we live with ambiguity. We live with a whisper that could be life, or could be chemistry, wearing life's mask. But maybe ambiguity is the point. Maybe this is what it feels like to stand on the edge of knowing, to feel the breath across aeons, but not yet know if it came from lungs or from stone. Think of Earth 4 billion years ago, before forests, before animals, before the sky turned blue. What evidence would remain if we looked back with Perseverance's eyes, mudstone with organics? Redox minerals, subtle textures in sediment, exactly what we now see on Mars. In our own history, such signals were the prelude to everything. They were the soil in which biology took root. They were the fragile beginnings of us. And if Mars shows us the same prelude, does that not suggest the play was performed there too? The organic signal of Jezero is not an announcement. It is not a trumpet blast of proof. It is a murmur, a molecule preserved in stone, a fingerprint that may or may not belong to life. But it is also the most intimate evidence yet that Mars once held chemistry on the verge of biology, that the line between lifeless and living may have been crossed, if only briefly, on that distant world. In the end, organics are not enough, but they are everything. They are the starting point of life, the scaffolding of possibility, the alphabet waiting to become story. And if Mars kept them safe for billions of years, then it kept safe the question that now haunts us. Are we alone? The organic signal has no voice. It does not answer. It only lingers, faint but insistent, in the rocks of a vanished lake, waiting for us to learn how to listen. When chemistry arranges itself with purpose, is that intelligence or coincidence? The leopard spots of Jezero are not decoration. They are a puzzle, written in stone, staring back at us with questions that strike deeper than geology. Imagine circles within circles, dark halos encased in lighter bands, each one a boundary between one chemical state and another. Iron shifts here, sulfur rearranges there, phosphorus binds quietly in between. And nestled in the heart of these halos, organics whisper like ink in the center of a target. To a geologist, this is fascinating. To an astrobiologist, it is electrifying. For on Earth, these same patterns, concentric zones of mineral change, are more than just chemistry. They are the fingerprints of microbial life at work. In oxygen-poor sediments, microbes push against gradients, living on the edge between what can be breathed and what cannot. Their activity leaves behind mineral rings, structures that resemble the concentric ripples of a stone dropped into water. To find such ripples fossilized into Martian mud is to glimpse the shadow of a process we recognize. But the puzzle lies in interpretation. Are these halos truly biological in origin, or are they the clever trick of geology, mimicking life with no life at all behind them? The line between pattern and purpose is thin, fragile, easily crossed. On Earth, similar mineral pairings, vivianite, greigite, emerge where microbes once feasted on iron and sulfur, leaving their metabolic echoes in the mud. On Mars, the same association appears in Sapphire Canyon, entangled with organics. It is a riddle that asks, do minerals copy biology, or does biology copy minerals? Think of it this way. Chemistry is the stage, but biology is the performance. The leopard spots are the stage set intricate, suggestive, already hinting at the drama that might have unfolded there. But the actors? They remain unseen. And yet, how haunting it is to see these patterns at all. For billions of years, Mars has been silent. Its rivers dried, its atmosphere thinned, its surface became a barren expanse of rock and dust. And still, beneath all that silence, these concentric whispers waited, not erased, not destroyed, preserved. Patterns matter because they speak of context. Random organics scattered through rock are noise, but organics placed at the center of redox halos, aligned with minerals like vivianite and greigite, become signal. It is as though nature were arranging clues not haphazardly, but with precision: carbon here, iron there, sulfur wrapping around them, a geometry of possibility. The human mind is trained to see patterns. We see faces in clouds, shapes in stars, destiny in coincidence. But sometimes, patterns are not projections. Sometimes, they are real. And the challenge for science is to know which is which. NASA calls this a potential biosignature, precisely because of the pattern. It is not just one clue, it is the co-location of clues, their choreography, organics with redox minerals, leopard spots like microbial fossils, contexts that echo Earth's biology. Alone, each sign is weak. Together, they hum with implication. But here is the paradox that humbles us. On Earth, these would almost certainly be read as life. On Mars, they remain ambiguous. The difference is not in the evidence, it is in our caution. For Mars is alien. Its chemistry is older, stranger, more prone to tricks. What looks like life may be the echo of some abiotic process we do not yet understand. And so, the puzzle deepens. What does it mean to see a pattern we cannot yet name? Are we witnessing the residue of alien microbes, long extinct, their final breath fossilized into stone? Or are we staring at a mirage, the planet itself playing with gradients, weaving order from lifelessness? Philosophically, this tension is profound, for if life is merely one expression of the universe's hunger for pattern, then perhaps biology is not special. It is simply chemistry given enough time and freedom. The leopard spots may be the boundary between those two truths. Picture it. 4 billion years ago, a lake ripples in Jezero. Sediment drifts down, carrying iron, sulfur, phosphorus. Perhaps, in that quiet water, life stirs, feeding on gradients, leaving behind chemical halos. Or perhaps the water alone, without biology, arranges the same halos through its own restless chemistry. Either way, the stone remembers. And either way, the puzzle remains unsolved until the rocks come home. The rover has given us an image, a target of organics, surrounded by mineral rings, concentric whispers in mud. To some, it looks like biology's signature. To others, like coincidence. Both interpretations hover, neither collapsing, and maybe that is the beauty of it. The leopard spots are not just a puzzle of Mars, they are a puzzle of us, of how we decide what life is, of how we recognize kinship in the cosmos, of how much uncertainty we are willing to live with. For now, the puzzle waits. The spots remain silent, their story sealed in titanium tubes, waiting for Earth's laboratories, waiting for the day when patterns become proof, or when proof remains forever out of reach. Until then, we are left with a haunting question. When chemistry begins to look like intention, how do we know where life begins? Even without life, the universe paints masterpieces in the mud. Not every pattern is alive. Not every whisper belongs to a voice. The cosmos, in its vast indifference, has always been capable of trickery, of arranging matter into forms that look purposeful, but are not. On Earth, life bends chemistry into intention. On Mars, perhaps chemistry alone is enough. The leopard spots of Jezero, those halos of organics, iron, sulfur, phosphorus, feel familiar to us because we have seen them before, shaped by microbes in Earth's lakes and swamps. But Mars is not Earth. Its waters were colder, thinner, fleeting. Its atmosphere was stripped away. Its chemistry, uncorrected by the constant editing of biology, may have followed alien rules. What if those rules, on their own, could sculpt the same patterns? Science must ask this question, not to dim wonder, but to protect it. Because if we leap too quickly to life, we risk mistaking the artistry of nature for something it is not. And yet, what artistry at Island? Abiotic explanations for Jezero's halos exist, though each feels like a ghost trail, fading into uncertainty. Some propose that high-temperature alteration, perhaps hydrothermal systems deep beneath the crust, could have rearranged minerals into the same patterns we now see. But the context is wrong. The minerals identified, especially vivianite, do not fit such a fiery past. They are fragile, easily destroyed by heat. If hydrothermal activity forged them, its touch was impossibly delicate. Others suggest acidic fluids may have swept through the mud, stripping elements, leaving halos behind. But again, the evidence resists. These rocks do not show scars of acidity. They whisper of gentle, neutral waters, not corrosive floods. The lake of Jezero was no acid bath, it was calm, still, preserving rather than erasing, which leaves the most subtle possibility: low temperature organo-catalysis. In this vision, carbon molecules arriving perhaps from space, or synthesized in the Martian atmosphere, settled into mud and became reactive agents, encouraging minerals to form halos without biology. Organics as catalysts, not as cells. A planet shaping itself in ways that mimic metabolism. without ever crossing into life. It is a possibility science cannot ignore, for Mars, untouched by biology, may have wandered paths we do not fully know. And perhaps in those paths lies the answer, that life is not necessary for patterns, that intention is not required for beauty. But here, we must pause, because even if these halos are abiotic, even if they are nothing more than chemistry's illusions, does that diminish their wonder, or does it make them more profound? Consider this: the same universe that gave rise to galaxies also gave rise to these patterns in Martian mud. They may be microbial fossils, or they may be the artistry of lifeless matter, arranging itself into forms that resemble life. Both are extraordinary. Both reveal a cosmos capable of complexity we barely comprehend. And yet, there is still the tug, the haunting resemblance to Earth. On our world, such patterns almost always mean biology. On Mars, they might not. The echo is there, but the source remains hidden. An echo of life, or an echo of chemistry pretending to be alive. This is the knife's edge where science lives between yearning and doubt, between recognition and restraint. To claim life too early is to betray the discipline that makes the discovery meaningful. To deny it too quickly is to blind ourselves to possibility. And so we hover in the in-between, listening to echoes that may or may not be voices. Philosophically, this tension is staggering. If Mars can create lifelike patterns without life, what does that say about us? About biology? Perhaps life is not as unique as we think. Perhaps biology is only one form of a universal drive toward pattern, order, and self-organization. Perhaps the leopard spots of Jezero are not the ghosts of Martian microbes, but the fingerprints of a universe that constantly toys with the boundary between living and not living. Even so, there is one truth that cannot be erased. The rocks remember, whether by microbes or by chemistry. These halos were written into Martian stone billions of years ago, and in their memory, they carry a question back to us. What is life, really? A process? A pattern? A persistence of chemistry? Or something more? Until we bring these samples back to Earth, the echoes will remain ambiguous. For now, the halos are neither proof nor disproof. They are echoes. And echoes, whether biological or abiotic, always demand that we lean in closer, listen harder, and ask again what it is we are hearing. Sometimes, the absence of something tells the loudest truth. Science often advances not by what is found, but by what is not. A fossil that should be there, but isn't. A signal expected, but silent. In the story of Mars, the silences speak as loudly as the discoveries. And in Jezero Crater, where Perseverance has drilled into mudstone and uncovered organics, minerals, and patterns, the most haunting element is what has not been seen. No chirality, the molecular handedness that life insists upon. On Earth, life selects one hand of molecules, left-handed amino acids, right-handed sugars, while abiotic chemistry produces both indiscriminately. The stones of Jezero have whispered of carbon, but they have not yet shown us which hand, if any, they favor. Without chirality, the whisper remains incomplete. No isotopic fractionation. On Earth, life alters the ratios of isotopes carbon 1,2 and carbon 1,3, sulfur 3,2 and sulfur 3,4, because living processes are biased, selective, purposeful. Biology leaves fingerprints in isotopes, subtle shifts that betray metabolism. On Mars, Perseverance cannot measure these ratios with precision. The isotopic voice, if it exists, remains mute. No cell walls, no microfossils, no obvious shapes of organisms preserved in the stone. The textures we see, the leopard spots, the halos, are geochemical, suggestive, but the unmistakable geometry of biology, the rounded cell, the filament, the branching pattern, these are absent or beyond the rover's sight. This absence is not failure, it is honesty, because absence is itself a form of evidence. It tells us the limits of what we know and the distance between hint and proof. The leopard spots say, maybe. The organics say, possibly. The silence of chirality, isotopes, microfossils says, not yet. And yet, absence carries its own paradox. Sometimes, What we do not see is not because it is not there, but because we are not looking deeply enough. The instruments of Perseverance, as powerful as they are, cannot reach into the nanoscale, cannot pass isotopes with laboratory precision, cannot peer into the molecular handedness of Martian carbon. To know these things, the samples must come home. The absence is not final, it is temporary, a pause in the story, not its end. Philosophically, this becomes profound, for absence is the tension between silence and anticipation. When we search the stars for alien signals, their silence is data. When we probe the rocks of Mars and find no proof, that too is data. The universe is not obliged to speak in ways we understand, and yet the silence draws us in, compels us to listen harder, to invent better instruments, to risk more daring journeys. Absence is also humility. It prevents us from mistaking longing for knowledge. It forces us to accept that even with the best machines, the clearest rocks, the most suggestive signals, we still stand at the edge of mystery, and at that edge, patience is the only path. But perhaps the deepest meaning of absence is this: life is not defined by presence alone, it is defined by memory, by what it leaves behind. If Jezero's mudstone hides traces too small for us to see now, that is still life's defiance against erasure. If we must wait for Earth's laboratories to detect chirality, isotopes, nanotextures, then absence today may become presence tomorrow. And so, the silence in Jezero is not empty. It is pregnant with possibility. It is the pause before the note, the blank space that makes the pattern visible. Sometimes, what is missing tells us more than what is found. Sometimes, the whisper is clearest when the voice itself cannot be heard. In this way, absence becomes its own kind of biosignature, not proof of life, but proof of mystery. A signature that says, look closer, dig deeper, wait longer. The rocks of Jezero are not lying. They are not hiding. They are simply holding their secrets until the moment we are ready to unlock them. Until then, absence will remain the loudest signal of all. We search Mars not just for life, but for ourselves, reflected in red stone. Every rock we examine on Mars is a mirror, not of our faces, but of our history, our assumptions, our hunger to find something familiar in the alien. When Perseverance peers into Jezero's mudstone, when Sherlock shines its ultraviolet light across ancient minerals, it is not only Mars being studied, it is Earth, refracted back through time and distance. Because we cannot help it, we interpret Mars through the lens of Earth. When we see Vivianite, we remember the swamps of our planet, where it blooms blue in waterlogged sediments. When we see Greigite, we recall the magnetic bacteria of Earth's lakes and estuaries, microbes that sculpt iron-sulfur minerals into microscopic architecture. When we see leopard spots in Martian mudstone, our minds leap to Earth's anoxic basins, to microbial mats etched in stone. This is not bias, it is necessity. For what else can we use as a guide but the one planet we know with life? Earth is the template, the reference, the control experiment. Without it, Mars is just red silence. With it, Mars becomes a question. Could what happened here have also happened there? And yet, the mirror deceives as much as it reveals. Mars is not Earth. Its lakes were shallower, its atmosphere thinner, its chemistry older and less corrected by biology. The same patterns may mean different things. What on Earth would almost certainly be biogenic might on Mars be abiotic echoes. The mirror reflects, but it also distorts. This duality is haunting. On one hand, the comparison gives us hope. If Earth and Mars shared conditions, then life should not be rare. On the other hand, the divergence reminds us of fragility. If Mars lost its chance, could Earth lose its own? Consider the timeline. Earth and Mars were once twins, warm, wet, dynamic. Both bore rivers, lakes, even oceans. On Earth, life took hold. On Mars, we are not yet sure. Somewhere, their paths diverged. Earth kept its atmosphere, its magnetic shield, its balance of greenhouse gases. Mars did not. Its sky thinned, its water vanished, its surface froze. The same beginnings, different outcomes. And in that difference, we see ourselves not as permanent, but as contingent, not inevitable, but lucky. This is the existential power of Mars. It is not just a place we study, but a version of Earth that could have been. A mirror showing us an alternate history, a warning, a reminder of what is fragile about our own world. And if life did exist there even briefly, even only as microbes in mudstone, then the mirror becomes even sharper. It would mean life is not unique to Earth, that biology is not a miracle, but a tendency, that wherever water lingers, organics gather, and gradients exist, life may spark, not just here, everywhere. But if no life ever emerged on Mars, if the leopard spots are only chemistry, if the organics are only meteorite dust, then the mirror still speaks. It tells us that conditions alone are not enough, that a planet can have water, organics, minerals, and still remain barren. That life is rarer than we imagine, more fragile, more contingent on hidden factors we do not yet understand. Either way, the mirror matters. Either way, we learn not only about Mars, but about ourselves. The anthropomorphic filter, the tendency to see Earth in everything, cuts both ways. It may mislead us, tempting us to see microbes where there are none, but it may also be the key, for perhaps Earth is not an exception, but an example. Perhaps by holding up this mirror, we glimpse not our bias, but our destiny, a universe where life arises wherever it can. And so, when Perseverance drills into Martian mudstone, it is not only hunting for alien fossils, it is holding up a mirror, and in that mirror, we are forced to confront two possibilities: that we are not alone, or that we are. Both possibilities shake the foundations of what it means to be human. Because if life exists beyond Earth, even once, even long ago, then the universe is alive in more than one place. And if it does not, then the miracle of Earth is more staggering than we ever dared believe. In either case, the mirror changes us. Mars reflects not just its own past, but our future. It forces us to ask, are we the lucky planet that endured, or the fragile one that will fade? The mirror of Earth in Martian stone does not give answers. It only returns our gaze, silently, insistently, until we recognize ourselves in the red dust. We built a machine to read stone like scripture. When humanity wanted to know if Mars had ever known life, we did not send a poet, a philosopher, or a prophet. We sent a machine. A rover named Perseverance, born of metal and fire, carrying eyes sharper than our own, ears tuned not to sound, but to the faint signatures of molecules and minerals. We sent an emissary of silence to listen to stone. Perseverance is not merely a rover. It is a library of instruments, each one designed to interrogate the Martian past with a different kind of question. Its cameras sweep across landscapes, capturing the geometry of cliffs and deltas. Its drills bite into rock, extracting cores like chapters pulled from the body of a planet. But its most delicate tools, Sherlock and Pixel, are the interpreters, the translators of stone. Sherlock, the scanning habitable environments with Raman and luminescence for organics and chemicals, uses ultraviolet light to make molecules sing. A laser excites electrons, and their glow reveals structure. With this glow, Sherlock detects organics, mapping where carbon-based molecules hide within the stone. It does not see life, it sees the alphabet of life, and when it swept across the mudstone of Sapphire Canyon, it revealed the organic signal precisely co-located with mineral halos, like ink placed deliberately on a page. Beside it works Pixel, the planetary instrument for X-ray lithochemistry. Pixel scans rocks at microscopic scales, bombarding them with X-rays, reading the elemental composition of each pixel in its view. It can tell us where iron gathers, where sulfur lingers, where phosphorus hides. Together with Sherlock, it does more than measure, it maps relationships, showing us that organics and minerals are not scattered randomly, but locked in patterns. These are not just tools, they are ears pressed against the walls of time, listening for the faintest echoes. Even more, Perseverance carries SuperCam, a laser that vaporizes rock from meters away, analyzing the plasma it creates to learn the chemistry of distant targets. It carries Mastcam-Z, stereoscopic eyes that zoom into landscapes and let scientists walk virtually across Martian deltas. It carries ground-penetrating radar, sniffers for weather, microphones that hear the thin Martian wind, a symphony of senses, assembled to turn a barren crater into testimony. Think of what this means. On Earth, entire laboratories are needed to detect organics, to map minerals, to analyze chemical halos. On Mars, a car-sized robot does it alone, millions of miles away, with no human hand to adjust a wire, no scientist leaning over its shoulder. Perseverance is not just a rover, it is humanity's laboratory on wheels, our ears in a place we cannot yet stand. And yet, for all its brilliance, Perseverance is limited. It can suggest but not prove. It can hint but not decide. It can read the text of Martian rocks, but not grasp their full meaning. Proof of life requires more than listening. It requires dissection, precision, instruments that cannot yet be miniaturized enough for a rover's frame. For that, the rocks must come home. Still, what Perseverance has already given us is extraordinary. For the first time, we are not just looking at Mars from orbit. We are reading its rocks at the level of molecules, pixels, and microtextures. We are not only seeing landscapes, we are seeing stories written within them. There is a quiet poetry to this. Humanity once imagined alien civilizations on Mars, canals carved by intelligence, signals sent across space. What we found instead is subtler, quieter, more humbling. The possibility of microbes, of chemical whispers, of life so small it leaves no monument but the arrangement of minerals in mud. And yet, to hear such whispers requires genius. Lasers, X-rays, spectrometers, robots that land themselves with rockets and AI. We are, in a sense, overbuilding for humility, building machines of staggering complexity to detect whispers so faint we might miss them otherwise. This is the paradox of Perseverance. It is the most human thing we have ever sent to another world, built not to proclaim life, but to listen for it. Imagine the rover, alone in Jezero, its wheels tracing the dust, its mast scanning cliffs, its laser firing silently into stone. It is a solitary pilgrim in a desert of time, searching not for treasure but for memory, and in that memory, for kinship. Perseverance is not just a machine, it is a mirror of us, our curiosity, our hunger, our longing to know if we are alone. It listens to rocks because we asked it to, because in those rocks we suspect there may be echoes of our deepest question. Are we unique, or are we one of many? The answer has not yet come, but the instruments have spoken enough to make us listen harder, enough to remind us that the universe may keep its secrets in stone, waiting for the right kind of machine to ask the right kind of question. And when Perseverance sends back its data, pixel by pixel, molecule by molecule, we are reminded of something profound, that we built a machine not to conquer Mars, but to listen to it, to let a dead planet speak, and perhaps, in its whisper, to hear the living truth. Mars has been speaking to us for centuries. It's only now that we're learning how to listen. The search for life on Mars is not new. It is a story as old as our telescopes, as ancient as our imagination. In the 19th century, when astronomers turned their lenses toward the red planet, they thought they saw canals, long, straight lines stretching across its face. Percival Lowell spoke of an intelligent race, desperate and ingenious, irrigating a dying world. It was illusion, of course, shadows and optical tricks, but it was also the first seed of hope. Then came the Viking landers in the 1970 seconds, two robotic emissaries that touched down on Martian soil, carrying experiments designed to detect metabolism. At first, the results startled strange chemical reactions that looked like life-breathing, but then came doubt and reinterpretation. What Viking had found could be explained by chemistry alone. For decades, the verdict was silence. The canals were illusions. The Viking signal was an echo of soil chemistry. Mars remained a barren rock. In 1996, the hope returned. A meteorite found in Antarctica, ALH 84001, was revealed to have come from Mars. Inside it, Tiny structures looked like fossils, microscopic worms etched into stone. The announcement electrified the world. Life on Mars. The US president addressed the nation. Headlines proclaimed a second Genesis. But again, the dream faltered. The structures were too small, too ambiguous, too easily explained by mineral processes. Once more, hope collapsed into uncertainty. Yet we did not stop listening. We built better instruments, asked sharper questions. Curiosity rover, landing in 2012, found organic molecules in Martian rock and methane in its thin air. The methane even seemed to change with the seasons, as if exhaled by something deep underground. But methane, like organics, is a trickster. Volcanoes can make it. Rock-water interactions can make it. Life can make it. The ambiguity remained. And now, Perseverance. Not just a rover, but the culmination of a century of longing. It does not look for life in the present. It looks for its fingerprints in the past, in the layers of Jezero Crater, in the stones that remember. And what it has found, mudstone cores with organics, minerals, and leopard spot textures NASA calls the closest sign yet. A timeline of disappointment bending toward possibility. Notice the arc. Illusions of canals, ambiguous Viking signals, contested meteorite fossils, methane plumes, Curiosity's organics, and now, Sapphire Canyon. Each step sharper, each clue clearer. The dream has not been abandoned, it has been refined. What was once imagination has become data. What was once myth has become measurement. This is the timeline of hope. Not a straight path, but a spiral, circling closer with each generation. Each failure teaches us how to ask better questions. Each silence prepares us for the next whisper. And now we stand on the cusp of something extraordinary. For the first time, we have a sample, a rock sealed in titanium, waiting to come home. Mars' sample return will be the ultimate chapter, the moment when whispers can be tested with the full arsenal of Earth's laboratories. A mission that may not arrive until the 2032, but one that promises answers that no rover can give. Think of that, a rock that has waited billions of years for us, waiting now in a tube the size of a chalkboard eraser, sitting on the Martian surface, waiting for a handoff across decades and millions of miles. A rock that could change everything we know about life. But even beyond science, the timeline is a story about us, about our refusal to stop asking the question, about our willingness to build machine after machine, to send them across gulfs of space, just to listen to silence more carefully. Each disappointment could have been the end. Instead, it became a prelude. Mars has been speaking to us for centuries. At first we imagined its voice, then we misheard it, then we mistook echoes for words. But now, finally, we may be hearing its true whisper. A whisper not of civilizations or canals, but of microbes, minerals, and mud. A whisper that may tell us that life is not unique, not lonely, not ours alone. And if that whisper proves true, then this timeline of hope will not end on Mars. It will extend outward toward Europa, Enceladus, Titan, exoplanets orbiting distant suns. Mars is not the only world with stories to tell. It is simply the first one close enough for us to hear clearly. The story of Mars is the story of hope deferred, but never extinguished. A story that reminds us, sometimes truth does not arrive in trumpet blasts. Sometimes it comes in echoes, across decades, across missions, across generations. Sometimes the universe speaks slowly, so that we may learn patience enough to hear it. A truth seen from afar is only a question in disguise. We stand on the edge of revelation, but the edge is not the summit. The discoveries of Perseverance organics, leopard spot textures, redox minerals are extraordinary. They are the closest evidence yet of life on Mars. And yet, they are not proof. Proof, in science, is a cathedral built stone by stone, with methods so rigorous that doubt cannot enter. What Perseverance has given us are blueprints for that cathedral. But the cathedral itself must be built on Earth. To know for certain whether Jezero's mudstone preserves biology, we must bring the samples home. Only in the laboratories of Earth can we perform the decisive tests, the ones no rover can carry in its metal frame. These tests are the keys to separating chemistry from biology, coincidence from intention. We will look at isotopes, the fingerprints of metabolism. On Earth, living things prefer lighter isotopes, carbon 1,2 over carbon 1,3, sulfur 3,2 over sulfur 3,4, leaving behind ratios that no random chemistry mimics. If Mars shows these biases, it would be like hearing life's accent across billions of years. We will study chirality, the handedness of molecules. Life chooses sides. Our amino acids are left-handed, our sugars right-handed. Pure chemistry produces both hands equally, but biology is biased, consistent, insistent. If Martian organics show the same asymmetry, it would be the closest thing to a signature, a choice written into carbon by living processes. We will measure clumped isotopes, which can reveal the temperatures at which molecules formed. Life on Earth thrives in narrow ranges, and these isotopic thermometers could tell us if Mars's organics were forged in the warmth of biology or in the cold indifference of chemistry. We will search for nanotextures, microscopic structures, where biology leaves traces, cell walls fossilized in minerals, filaments of microbial mats, arrangements too precise for chaos. These are whispers Perseverance cannot hear, but which electron microscopes on Earth can. And we will seek molecular structures, the complex patterns of carbon chains and rings that life favors. Proteins, lipids, nucleic acid fragments, even degraded, their architecture carries the logic of biology. If Mars's organics are random, they may be abiotic. If they are structured, they may be alive, or once were. These are not guesses, they are decisive, and they can only be done here in Earth's laboratories, which is why Mars sample return is not a side mission, it is the mission, the most ambitious planetary project ever conceived. To land on Mars, retrieve Perseverance's sealed cores, launch them back into orbit, and ferry them across interplanetary space to Earth. A relay race across worlds, carrying rocks that may hold the second Genesis. But the stakes are more than scientific, they are existential. If we open those tubes and find isotopes, chirality, molecular patterns consistent with life, humanity's understanding of itself will change forever. We will know that Earth is not the singular cradle. That life, however small, once breathed on another planet, and if it happened there, it could happen anywhere. And if we open the tubes and find nothing, if the organics are abiotic, the textures geological, the whispers illusions, then the silence speaks too. It tells us that conditions alone are not enough, that Earth's spark is rare, fragile, perhaps unique, that we are, after all, alone in a universe that favors chemistry but not biology. Either answer is profound. Either answer reshapes what it means to be human. But until the samples come home, until the tests are run, proof will remain out of reach. We have questions dressed as answers, possibilities disguised as evidence. We have whispers, not voices. And so, we wait. The tubes lie silent on Mars, Perseverance their guardian, dust their blanket, time their companion. They may wait a decade before human hands touch them. But in that wait lies the weight of history. For never before has a question so ancient are we alone, rested so literally in our hands. Proof requires patience. Proof requires humility. Proof requires Earth. And proof, when it comes, will be more than data. It will be destiny. What changes more, Mars or us, when we believe we've found life? Science often pretends to be cold, detached, objective. Numbers on a page, graphs on a screen, data stripped of meaning. But beneath every discovery lies something deeper, something unspoken, the weight of what it would mean for us. And nowhere is that weight heavier than in the search for life beyond Earth. Because the truth is, when we look to Mars, we are not only asking if it was alive, we are asking what that answer would do to us. Imagine it, the samples return, and inside them we find the unmistakable fingerprints of biology. The isotope ratios tilt in ways only life could produce. The molecules favor one hand over another. Nanotextures reveal cell walls fossilized in Martian stone. Proof, undeniable. What would that do to our sense of who we are? Religions would revisit their texts. Philosophers would rewrite their treatises. Children would look up at the sky and know we are not unique. Life is not Earth's solitary miracle. It is a cosmic tendency, a rhythm that beats wherever water, organics, and time conspire. That realization would not shrink us. It would expand us, binding us to a universe alive in more ways than we imagined. But imagine the opposite. Imagine the samples return, and every test comes back empty of biology. The organics are random, the isotopes indifferent, the halos geological. No proof. Silence confirmed. What then? What would that say about life's rarity? That Earth may not only be unique, it may be fragile, an outlier in a cosmos that prefers chemistry without biology. That would not expand us. It would isolate us. It would place a burden of responsibility on humanity. If life is this rare, then its survival depends on us. Both outcomes are seismic. Both outcomes change us more than they change Mars. For Mars, either way, remains the same, a red planet with a silent crater. But for us, the meaning shifts. One path opens the door to cosmic kinship. The other confronts us with cosmic solitude. And here lies the paradox. Whichever answer comes, it forces us to evolve. If we are not alone, then the universe is full of neighbors we may one day meet, learn from, or fear. If we are alone, then we become the sole stewards of consciousness, the only flame of awareness in an endless dark. Both truths carry awe. Both truths carry responsibility. This is why NASA, ESA, and scientists across the world are careful. This is why they say potential biosignature instead of life. Because the stakes are not only scientific, they are existential. To declare life too early would risk not just credibility, but meaning. To declare it too late would risk missing our place in history. The word itself, life, becomes heavy, as though the entire weight of humanity balances on its syllables. Think about how civilizations have reacted to smaller discoveries. When Copernicus placed the sun at the center, humanity's self-image fractured. When Darwin spoke of evolution, our sense of uniqueness trembled. Proof of life beyond Earth would be larger than both. It would not only redefine our place in the cosmos, it would redefine what the cosmos island. Is it alive in many places, or only here? Is it a chorus, or a solo? Philosophically, the question is not whether Mars had life. The question is whether humanity can bear either answer. Because if we discover life on Mars, we must accept that biology is not rare, that the universe may teem with it, that we may someday face the ethical, spiritual, and practical challenges of sharing existence with others. And if we do not discover life, we must accept the crushing weight that everything, every song, every dream, every act of love exists only here, on this pale blue dot, in the fragile cradle of Earth. This is the true payload Perseverance carries. Not just rocks, not just organics, not just patterns, but a mirror held up to our species, forcing us to confront who we are and what role we play in the cosmos. The rover is not only collecting stone, it is carrying a question, and when that question is answered, it will be us, not Mars, that changes forever. So perhaps the most profound discovery is not out there, in Jezero's mudstone. Perhaps it is here, within us, in the way we respond. Mars is the stage, we are the actors. And the story is not just about what Mars once was, it is about what we will become when the answer arrives. The universe never shouts, it whispers in frequencies of silence. Stand outside on a clear night, and you will notice something strange. The stars blaze, but the space between them is quiet, almost unbearably so. For all our telescopes, for all our antennas scanning the skies, the cosmos has never shouted its secrets. It has only whispered, and more often than not, it has kept its silence. Mars, too, is silent. Its rivers have dried, its winds carry only dust, its sky is thin and pale. When we send rovers, when we drill its stone, we do not find monuments or fossils or unmistakable relics of life. We find halos, spots, molecules, suggestive, haunting, but incomplete. This is the quiet between planets, the silence that stretches not in distance but in meaning. The silence is not empty, it is full of possibility, just as the night sky is filled with invisible radio waves, neutrinos, dark matter we cannot touch, so too is Mars filled with hidden stories we cannot yet decipher. Silence is data. Silence is a canvas waiting for interpretation. Think of the Fermi paradox, the question of why. In a universe so vast, we hear nothing from other civilizations. Why the skies remain mute? Perhaps the answer is simple. The universe speaks in whispers, not in shouts. Life leaves faint traces, subtle patterns in mudstone, organics clinging to mineral fronts, echoes in isotopes. It does not broadcast. It does not proclaim. It waits for someone patient enough to listen. This is what perseverance has taught us, to lean closer into silence, to hear the faintest notes, to recognize that the absence of proof is not proof of absence, but the quiet between phrases in a longer sentence. Mars is not shouting life at us. It is pausing, letting us fill in the gaps, asking us to listen harder. Silence is not failure. Silence is invitation. It draws us forward, compels us to send more machines, to plan bolder missions, to dream of human footsteps in Jezero's dust. If Mars had given us an obvious fossil, a Martian leaf pressed into stone, our journey would have ended quickly. But silence demands perseverance. It demands that we keep going, keep asking, keep wondering. And there is something deeply human in that, for we too are born of silence. The cosmos did not announce us. It sculpted us slowly, atom by atom, cell by cell, over billions of years, until suddenly we could speak. If we are the voice of the universe, then silence is our parent. So when Mars gives us ambiguity instead of clarity, whispers instead of declarations, perhaps it is not hiding the truth. Perhaps it is teaching us how truth really arrives, slowly, quietly, as possibility before certainty. The quiet between planets is not just distance measured in miles. It is the interval between question and answer, between evidence and proof. And in that interval, we discover not only the cosmos, but ourselves, our capacity for patience, for humility, for wonder. Someday, the silence will break. Someday, the samples will come home, and the whispers will either resolve into voices or fade into noise. But until then, the quiet remains. And perhaps, in that quiet, lies the deepest lesson of all, that the universe speaks most profoundly, not in what it says, but in what it withholds. In seeking Martians, we discovered the Martians were us. From the moment we first imagined canals on Mars, we projected ourselves onto the red planet. We dreamed of engineers carving rivers across a dying world, of civilizations struggling to survive in dust and silence. We looked at Mars and saw not its reality, but our reflection, our fears, our hopes, our destiny. Mars has always been a mirror. The discovery of organics and redox minerals in Jezero is no different. When we see leopard spots, we remember microbial mats on Earth. When we see Vivianite, we recall swamps and bogs that teem with unseen life. When we see greigite, we think of bacteria clustering iron and sulfur into chains of survival. Every observation on Mars loops back to Earth, back to what we know, back to ourselves. But what if this is the point? What if Mars is not meant to give us clear answers, but to reflect back the questions we are too afraid to ask? Questions about our fragility, our uniqueness, our place in the cosmos. Carl Sagan once wrote, "We are a way for the cosmos to know itself." Mars forces us to live this truth. By searching its stones, we are not only seeking Martian microbes, we are testing the very nature of existence. If life emerged twice in one solar system, then consciousness is not a fluke, it is destiny. But if Mars is sterile, then we are rarer than we imagined, perhaps the only eyes the universe has ever opened. And so Mars becomes less a planet and more a mirror. Every discovery reflects our longing to know if we are alone. Every ambiguity reflects our discomfort with uncertainty. Every whisper from its rocks reflects our deepest need to connect, to belong to something larger than ourselves. Psychologically, this is profound. The Martian search is not really about them, it is about us. It is about what kind of species we will become when confronted with either kinship or solitude. If life is common, we must prepare to share the universe. If life is rare, we must accept the weight of being its guardians. Either way, Mars reflects our responsibility. Even the rover's name, Perseverance, is a mirror. It embodies our refusal to give up on the question. For decades, disappointment has followed every Martian discovery. Canals, Viking signals, meteorite fossils, methane plumes, each one collapsing under scrutiny. Yet we return. We keep sending machines. We keep drilling stones. We persevere because in Mars's silence we see our own hunger to know. This mirror also reflects our fragility. Mars once had lakes, rivers, perhaps even oceans. Now it has none. What happened there could happen here. Its barren plains are a prophecy etched in dust. Atmospheres can vanish, climates can collapse, water can retreat forever. The mirror shows us not only what we might find, but what we might lose. And still, it shows us beauty. The mirror is not only a warning, but an invitation. If Mars once breathed, even briefly, then life is not a miracle confined to Earth. It is a thread woven into the fabric of the cosmos. And in that reflection, we glimpse something transcendent. We are not outsiders in a dead universe. We are participants in a living one. When we look into the Martian mirror, we are forced to confront both possibilities at once, that we are not alone and that we are. The reflection is paradox, ambiguity, wonder. It is the face of the cosmos looking back at us through red stone, asking, "Who are you? What will you do with this knowledge?" In the end, the Martian mirror does not give us answers. It gives us ourselves. If we are the only life in the universe, what now? Jezero Crater is quiet. The rover sits alone, its wheels etched into red dust, its tubes sealed with cores of mudstone and memory. Around it, the silence of Mars stretches endlessly, a silence older than Earth itself. And yet, within that silence lies the closest evidence we have ever held of another spark, another attempt by the cosmos to breathe. Organics bound to minerals, halos whispering of redox chemistry, patterns that could be coincidence or kinship. We have asked Mars if we are alone, and Mars has answered with ambiguity, not with fossils, not with ruins, not with certainty, but with a puzzle, a riddle etched into stone, enough to stir hope, enough to demand patience, enough to remind us that the greatest questions are not answered quickly. And so we wait. We wait for Mars' sample return, for the decade-long journey that will bring Jezero's rocks to Earth. We wait for the laboratories that will measure isotopes, pass chirality, search for textures so small they border on imagination. We wait for proof or for silence. And in that waiting, the question grows louder. What if we are alone? What if we are not? If we are not alone, if life existed on Mars, even once, even as microbes in mudstone, then biology is not a miracle, but a tendency. It means the universe is alive in more ways than we can see. It means the stars themselves may host cousins we have not met. It means our place is not at the center, but among countless others. And if we are alone, if Jezero's whispers dissolve into chemistry without intention, then we become something staggering. The only life the cosmos has ever known, the sole witness of its beauty, the only consciousness that asks why. In that case, the responsibility is crushing and sublime. For if life exists only here, then every song, every story, every act of kindness is infinitely precious. We are the guardians of awareness itself. Either answer is not the end of the story, but the beginning of one larger than we imagined. In the dust of Jezero, we glimpse ourselves fragile, curious, determined. We glimpse the paradox of existence, that we may be one among many or one alone, that either possibility carries wonder, that either possibility demands reverence. The rover drills, the samples wait, humanity listens, and the universe in its silence holds the answer close. But perhaps the deeper truth is this: by asking the question at all, we have already changed. We have already stepped beyond solitude, beyond ignorance. We have already become part of the cosmos in a new way, its curiosity, its self-reflection, its voice. So when we ask Mars if we are alone, and it answers only with whispers, we must remember, in that asking, we are already not alone, because we are here, together, searching. Because the question itself binds us to Mars, to the stars, to each other. We asked Mars if we were alone, and in the silence, in the waiting, in the persistence of our search, we discovered that we were not.